A star is torn apart, atom by atom, as it drifts too close to a ravenous, supermassive black hole. But this wasn't just any stellar death. It happened in the middle of a galactic collision, and for only the second time ever, we've caught it in the act. In a universe full of mysteries, some are so violent, so cataclysmic, they reshape galaxies. One such event just unfolded in a pair of colliding galaxies, where a supermassive black hole awoke and shredded a star. Known as a tidal disruption event, or TDE, this cosmic crime scene is offering astronomers a unique look at how black holes behave when galaxies merge. And it might just change how we understand galactic evolution itself. The event is called AT2022-2TN, and it occurred in the galaxy SDSSJ232323.79 plus 104107.7, a smaller spiral galaxy currently merging with a neighboring galaxy 10 times its size. The discovery was led by Francesca Onori of the National Institute for Astrophysics, INF, in Italy, and documented in a peer-reviewed study published on May 23, 2025 in the monthly notices of the Royal Astronomical Society. The team had been monitoring AT2022-UTN as part of a multi-wavelength campaign, combining optical, ultraviolet, and X-ray observations. The transient was originally flagged by the Zwicky Transient Facility, a robotic sky survey that scans for brief, luminous flashes across the cosmos. Using ground-based telescopes and space-based observatories, the researchers pieced together a complete light curve. Each photon carried with it a clue, an echo of a star in its final moments. These data streams, spread across multiple bands of the electromagnetic spectrum, told a story not just of destruction, but of transformation. The host galaxy itself is no stranger to turmoil. It's in the early stages of merging with a more massive companion. This interaction is already triggering bursts of star formation, but now researchers believe it also helped awaken the sleeping black hole at the galaxy's core. It's a dynamic, gravitationally chaotic environment, ideal conditions for feeding black holes with the matter they crave. Interestingly, this galactic pair has shown signs of tidal tails, massive arcs of stars and gas being stretched between them like cosmic tendrils. These streams signal that gravitational forces are already deeply at play, and the center of this storm is precisely where AT2022-2TN erupted. It's like observing a lightning bolt strike at the heart of a cosmic hurricane. Here's where things get strange. Most TDEs have a well-known signature. The star gets stretched by the black hole's gravity, forming a glowing, donut-shaped disk of debris. It usually brightens quickly, then fades over weeks or months. But at 2022 defied expectations. First, it showed an unusual plateau in brightness for 30 days. Instead of fading, the light curve held steady, then suddenly dropped in temperature. This sustained brightness suggests the presence of a reprocessing layer, or thick envelope of material, absorbing and re-emitting energy over time. Spectral analysis revealed strong helium and nitrogen emission lines, indicating a disrupted star low in hydrogen but rich in processed stellar material. This hints at a core stripped of its outer layers, perhaps the exposed heart of a red giant, one that had already shed its hydrogen envelope long before its fatal encounter. And then came the double-horned emission line, a feature rarely observed in these events. This pattern reveals high-speed orbital motion, where some debris is moving toward us and some away, with velocities of tens of thousands of kilometers per second. It's a fingerprint of a compact accretion disk spinning around the black hole at relativistic speeds. This wasn't just a flash in the night, it was a slow, methodical unraveling. One moment of stellar miscalculation triggered weeks of luminous drama, punctuated by high-energy X-ray silence and optical theatrics. The black hole wasn't just devouring, it was displaying. In the paper, Onori and her team suggest the star was completely disrupted by a supermassive black hole weighing about 1 million times the mass of the Sun. As the star disintegrated, the debris formed a glowing disk and launched a spherical, reprocessing envelope, an expanding cloud of matter that absorbed the high-energy light from the accretion process and re-radiated it in optical wavelengths. This envelope could explain the peculiar plateau. Acting like a thermal blanket, it cloaked the early stages of accretion before breaking apart and revealing the hot core. In their own words, this TDE shows a combination of features rarely seen together: spectral peculiarities, a thermal plateau, and post-peak temperature dip, the authors wrote. Its occurrence in an interacting galaxy adds to the growing evidence that such environments foster TDEs. It's worth noting how rare this is. A 2022 WTN is only the second tidal disruption event ever recorded in a galaxy undergoing a merger. The first, 2019 QIS, also exhibited unusual spectral traits. The recurrence of such events in merging galaxies suggests that these chaotic regions may be rich hunting grounds for black holes and rich observing grounds for astronomers. And yet, there's a bigger narrative hiding within this: the idea that these events are not rare at all, but simply poorly observed. With more sensitive instruments and persistent monitoring, we may begin to uncover an entire class of TDEs that exist at the intersection of stellar destruction and galactic transformation. New instruments like the Vera C. Rubin Observatory and missions such as ESA's Euclid and NASA's Roman Space Telescope may uncover dozens, perhaps even hundreds of TDEs each year, allowing us to map their frequency against cosmic structures. Each one will be like a flare illuminating the feeding habits of black holes. At 2022 TN, with its unique combination of features, is not just a curiosity. It may be a prototype for a class of TDEs we've rarely had the opportunity to study in detail. Galactic mergers are among the most consequential events in the universe. They don't just reshape galaxies, they reshape the lives of the black holes within them. When galaxies collide, their central black holes begin a slow gravitational spiral toward each other, a dance that can last hundreds of millions of years. In the process, vast reservoirs of gas and dust are destabilized. These materials are funneled toward the galactic center, providing dormant black holes with an energy buffet. Black holes that have sat quietly for eons suddenly have something to devour. And they don't just consume, they light up. Accretion can produce intense radiation, launch jets of particles at near light speed, and even blow star-forming gas out of galaxies, affecting their entire evolution. In this sense, TDEs are more than accidents. They're signs of a galactic heartbeat. The fact that we've now caught a tidal disruption event in progress during a galactic merger offers confirmation of a long-standing prediction: that cosmic collisions can directly fuel the most extreme gravitational engines in the universe. Moreover, TDEs serve as natural laboratories for probing strong gravity. They allow researchers to estimate black hole masses, test the limits of general relativity, and explore exotic states of matter in the accretion disk. Just as a seismologist reads the Earth's interior through the echoes of earthquakes, astronomers can now probe the depths of black holes through the violent collapse of stars. Every disruption, every flare is a message from the edge of space-time. As observatories become more powerful and sky surveys more frequent, events like AT 2022 TN may become crucial tools, not just for understanding black holes, but for understanding how galaxies, including our own Milky Way, evolve over cosmic time. And they may help us answer one of the most provocative questions in astrophysics. How often do supermassive black holes feed, and how does that feeding frenzy shape everything around them? A star's violent death, a galaxy in mid-collision, and a supermassive black hole awakened. A 2022 BUTN isn't just a discovery. It's a cosmic turning point, captured at just the right moment. More of these stories are waiting in the shadows, literally in the hearts of distant galaxies. So, If you want to keep exploring the strange, the violent, and the astonishing truth of our universe, subscribe to stay on the front line of discovery. This is only the beginning. How many more stars are about to be devoured?